So hello and welcome to the computer graphics practice session video, and this week's first task is soft particle chopper. So in this task we're going to create this scene. Actually we have the scene, but we're going to create a bunch of quads that have a transparent texture on them because there's many of those and they like move via some algorithms, they rotate around. Then let's call them particles, and if you just put a bunch of quads with images arbitrarily in your scene, then you probably end up with something like this. Some of them will clip through the walls or the floor, and this doesn't look good. So our aim in this task is to create kind of this result where they softly blend into the environment, into the scene. And in order to do this, the main idea of this algorithm kind of is that if we have some kind of a scene, and we have a camera, and let's say that we have a near plane and a far plane somewhere, and there are like different objects in the scene, maybe some kind of walls somewhere, then at the first step we want to store kind of the depth information of the scene. So we're going to use two rendering passes in this task. In the first pass we're going to look at the scene, look at the depth values for all of the fragments seen in the scene, and store them on a texture. So we won't render out to your viewport in the first pass, but we will render the scene onto a texture and the depth of the objects. So this would allow us to compare the depth of those objects afterwards with other objects, for example the particles. So the algorithm works like this, that if we have like another object here, which is now this particle quad, then we can kind of check that if we have a fragment that's rendered here, we can check what was the depth value at that pixel from the previous pass. So from the previous pass, this specific pixel value would have been that one, the depth value of that one. How far away is this thing from the origin of the camera? And you can see that currently those two would have very different depth value, so that's totally fine. We are not going to do anything fancy with this fragment. Let's draw it like it with the data it gets from the smoke texture. But let's say we have a fragment here, which is also like drawn at some position on the screen, and if we sample the same value from the previous pass, then that would be the fragment on this object and its depth value. And you can see that now those two would have a very similar depth value. The value we had from the previous pass stored is quite similar to the one we got now from this quad of smoke, or smoke quad or something. And in this case, what we want to do is we want to increase the transparency of the smoke particles fragment depending on the closeness to this scene geometry. And the closeness, we can just take the closeness of depth. So if an object is close to another, then it needs to be close in all dimensions, in x, y, and z. And something else we are going to need is that our space here is this right-handed coordinate system, so x, y, and z. And as you can see, the z-axis is pointing backwards, meaning that those things actually have negative values. test values. Like if you take the pure camera space test value, it will be negative, and furthermore it will be quite a huge value because our near plane, I think it was 1, and far plane was something like 30. So we get values like, I don't know, 12 here. But the texture we are drawing our scene onto can only hold values from 0 to 1. So this is also something we need to deal with at some point. But let's go look at the code for some time and see what's here. So we have the texture util from before, the shader util from before. In the geometry CPP, I've refactored some of the things like create quad and texture quad and sphere from the previous tasks as well. But what interests us is this main CPP. So yeah, init chopper, copy your chopper code here. Init particles. So this is something you should do, because if, currently it will give an error, but you can see that this particle vertex array object currently creates one texture quad. So what we want is we actually want to create many different particles here. So currently we add one position to these particle positions, but we want to add around 20 particles around anger, and then push all the values into the particle positions vector. So the idea is that when we're drawing the particles, we'll use the same vertex array object, but we'll draw them at different locations. What you can do here is you can find out how C++11 does random variables. I think it's really interesting. They have this distribution variable, and you can sample from the distribution. It's really like brings out what the random variable is, although it's like more than just one command. It's a few lines of code. But it's interesting to do it at least once if you haven't before. Yeah, currently don't try to prevent the intersection with anger walls. Now this next function, this is the depth render target. So this is required in order to create this other kind of render target or texture or a buffer where we're going to draw the results of the first pass onto. So this could probably be done in a more optimal way. So currently there is this RGBA here. Yeah, we could probably just use one channel, but yeah, it creates that. Draw anger, nothing to see there. Draw chopper, this is where you copy your chopper code. Draw particles. So this is where you want to like draw different particles. So you want to iterate over the particle positions. You want to rotate the different particles. You can like rotate some of them counterclockwise, some of them clockwise. Then of course the model matrix. Call bind vertex array to fetch the corresponding vertex array object. That's the particle one. And then call make the draw call. So this would draw the particles. It's kind of similar to what's going on up here. At one point we probably should like try to do this to at least some extent. So we're using like a couple of shaders. These are the variables. Oh, and so the particle shader would need a couple of things like the frustum. So this is the near and far plane. Of course, like frustum would also include the field of view, but yeah, so currently we only need these near and far plane values and the screen size, and we'll see later on why this is necessary. The depth shader, so this is the shader we use to like output the depth values of all of our scene objects. That will also need the near and far values. Okay, when we're rendering, so this is how we're rendering with like multiple passes. So first, we draw the hanger, but we draw the hanger with the depth shader onto the depth frame buffer. So we have we bind the frame buffer, depth frame buffer. This is the rendering target, not the screen, and draw the hanger with the depth shader onto that. Next, we return to like a screen rendering, so we set the frame buffer to 0, so this will render to the screen. Then we activate the particle shader, we send the depth render target result that we got from here to this particle shader as an uniform, and then we draw the scene normally with the corresponding shaders that objects have. So if I currently run this, I'm going to get an error that there is this variable texture that hasn't been used. So that's probably true because probably the quad code, so the particle vertex shader. Well, let's see. Yeah, there's lots of those. Remove these lines. We need to clean this up when we're ready to when we have used all the variables and don't need them anymore. So the problem is that otherwise, if you don't have those lines, then OpenShell will kind of optimize them out. But yeah, so this texture looks like this isn't used, so this 0, what if I put like 0.1 here, will I get some, yeah, so this worked, I got some room, so the hanger is now visible. But what we want to do, there are a couple of things, so first of all we could try to render the depth, and I think that might be. Actually, let's try to render the particle first. So it says iterate over lots of things and stuff. I'm not going to do this right now. I'm just going to call this. Where do I translate this? So let's put it in the center of the room and see from there. And we need particle vertex array object, and let's draw this one. Okay, now we have this red particle, but I actually don't want this to be in the center of the room, but perhaps to the left a bit and down somewhat, so that it would. Yeah, it's currently here, so it's hard for me to say if it actually clips with anything. I'm gonna, just in case, increase those values to 6. And let's see then. And now it probably clips with this wall, but we have to render the texture there to see this. Okay. So let's take the particle vertex shader. So we have already interpolating the UV, that's good. Let's take the fragment shader. So well, there's the task here. So you want the depth values of the particles, and you want to compare them with the previous depth values. But what we would like to do before that is just see that we actually get the texture here. So let's see what happens. Yeah, so now we're getting a texture, but we can see that the transparency kind of doesn't work. We have some texture here, but there's a problem with transparent values. And the problem kind of is that in order for the transparency to work, so we need to enable blending. So for this, let's go near the infinite loop here, or the throw loop, and there's the there's the task. So we need to enable alpha blending, so regular alpha blending, and we need to see the functions GL enable and GL blend func. So let's go see them. GL enable and GL blend func. Okay, so enable of course like enables different things, and here we can see that GL blend, and this is probably what we want to enable, right? Blending, so that if we have like two pixels in front of each other and one has transparency, then they will be blended together. GL enable, GL blend. But GL blend doesn't do anything by itself, as we discussed in the lecture. We also need to specify the blend func. So what actually happens with the pixels? What are the factors for the source and the destination pixel values, and how we get this result? So for alpha blending, if you don't remember, we can always go to materials, C for blending, and C color blending, and here we have conventional alpha blending. So the source factor is source alpha, and the destination factor is 1 minus source alpha. So this is how we blend those things together. So let's use GL blend func now, and let's specify the parameters of the general blending function as source factor is source alpha. Let's see, where is this? Let's GL source alpha is the first one, and the second one is 1 minus source alpha, so that's right here, GL 1 minus source alpha. And this will enable us conventional alpha blending. If you want some other blending, then just change the blend func and you get other blending modes. And let's see if this actually worked. So yeah, it's it's barely visible, but the blob of smoke is here, so you can see it. Now what I'm noticing is that it's still not clipping the wall, so I'm going to go back to where we had this thing and put 8s here, for example. Maybe we would want to like move. No, that's fine. So now it's pretty visible that this particle clips into the floor and into this wall here. Maybe these walls would be darker to better see this. But if you put like bunch of those particles around in the scene, then they all clip through the walls, and this is not what we want. Now, in order to get rid of this, let's try to deal with this depth information. And for this, what I want is to actually see the result of the rendering with the depth shader. So actually, just not to mess anything up, I'm going to comment out everything here and draw this hanger with the depth shader. Yeah, that should kind of do it. So let's see what happens. So currently I'm getting a black screen here, and now if you go to this depth shader flag, there are some values. No idea if we even end up here, so let's write some red colors here so that we can see it. Yeah, so there's some problem currently. This is also black. Okay, so it kind of turned out that we do need to use at least this line here as well. So now if we render this thing, we are getting a red window, and this is what we wrote in the fragment shader. Before there was this C. Now what this GL frag C is, it's the value that's written in the depth buffer. So you can see that it has some gradients, so the walls are kind of closer to the camera, so they're darker. There is white area here, if you can notice, but this value isn't linear. So this is why we are going to use it, because it would behave differently for soft particles that are further away from the camera or closer to the camera, and this is not what we want. If you want, and you probably need to know more about this GL chord. If you Google this, you find this built-in variable section in OpenShell, like wiki, and if you go down here, there is this fragment shader inputs. So GL chord is one of the built-in variables, and it says that it holds the location of the fragment in window space. So for each fragment, this GL chord will hold the XY coordinate in the window space, and the Z component is what's in the depth buffer. Okay, but what we want here would be to have the depth value which would also be normalized. So first thing we would want is to have the view space depth value. So for this, let's write an output variable float, let's call it d, and let's have this d as view position z. But not only this, because this view position is negative, we want to negate this. So now it's positive. But now it's from like 1 to 30, or what was, we can even check this out. So here we have near and far. Yeah, so far is 30, so it is 1 to 30. Remember this correctly. But what we want is for this to be from 0 to 1. And for this, you can think about how to convert some range from 1 to 30, let's write 30 here, to 0 to 1. So if you have a value here, this should be mapped into that. Maximum value should be mapped to 1, and minimum value should be mapped to 0. So this kind of mapping of one range to another is very useful and like often used in all sorts of different places. So how would I approach this is, so we have this, let's make some more room here. So we have this value x, so this is x, it's somewhere. And if we subtract 1 from it, then the minimum value now this can have is 0. Well, the maximum is 39, but minimum is 0. This would mean that we have mapped the first starting point of the range to 0. So this would be the first step, x minus the minimum value. This maps this to 0. Next, now we have values from 0 to 29, right? Because we have subtracted 1. So we need to scale this range down by dividing it with 29. And this is how we get this 29 is 30 minus 1. So the maximum value minus the minimum value. And this is pretty much it. So the minimum value is 0, maximum value is 1, because if this is x is 30, this is 29, 29 divided by 29 is 1, and we have successfully mapped this range from 1 to 30 to 0 to 1. Let's try to make this, let's try to make this in code as well. So we have this d, and we want d to be d minus the near value, which is the first element of this frustum vector, right? was near and far, and we want to divide this thing by the second value, the far plane, minus the near plane, and that would scale this value into the range 0 to 1. This isn't what we want yet, so what we are missing is, okay, we are writing this d varying value, but in the fragment shader we also need to take this float d, and what I'm going to do is output this in all 3 channels and see the result now. Yeah, so now we have this kind of result. So closer values have values closer to 0, 1 there, and it's quite linear. So if we want to kind of test this, what we can do is we have this near plane. Let's make this near plane 20, for example. We can compile, and what happens then is that part of the hanger is now clipped by this far plane, and you can see that the values in the edge here are near 1, so white, and yeah, so this is the linear depth that we wanted. Now let's put this back to 30, and now this result that we get from this depth shader by drawing the hanger with it, this we need to use in the subsequent step. So let's put this thing back here. Hopefully now this will be rendered into this depth frame buffer, which is then sent, well, the depth render target which holds this depth frame buffer is then sent to the second pass, and the particle shader should have access to it. So in order to test this, let's take the particle fragment shader, and currently we have sampled the values from the texture. So I'm going to use this color for this value for a moment, and now I would like to see like what is visible in the depth texture in this particle. So I'm going to override the color with texture 2D. Now this depth texture, another question is, where should I sample it? And this is the part where this GL frag chord comes into play again. So as you remember, this has values in screen space for the current fragment. But well, the screen space is however big our screen was, I think it was 640 or something. Well, we can't find this now, but we need to scale this down again to a range from 0 to 1, because our UV space is exactly in that range. So what we're going to do is take this GL frag chord and divide this with our screen size vector 2, and this should give us a value from 0 to 1. And let's see what do we get as output from this. And yeah, so now if we look at it, it's kind of like this window into this depth space. So basically now this particle shows us what are the values it got from this depth texture from the previous pass. And that's pretty much all we're going to do in this video. What you should do now is use this depth value, find the depth value for each pixel for the particle, and compare those two. And when you have compared those two, then you want to like change the alpha value of the color. So that might be something like times the depth difference that you get from subtracting one and the other. And if this like changes like in a bad way, then you can like multiply this with something like 4 and see what happens then, and tweak this as much as you need to get a visually good result. And yeah, so add different particles, make them rotate in a good way so that it's visually pleasing. One thing you should also note here, so when we are rendering transparent objects, then well, first of all, they need to be rendered after non-transparent objects. Another thing is that we want to render them from back to front. So we start rendering from back and move on to front. So this is why we kind of sort the particle positions vector here in this init particles function. So that when you loop over this thing in the draw particles place, so you need to loop over the positions and then translate them and do the rotation part as well. Then you end up with looping from back of the scene to front. Okay, and that's it about this. So hopefully you achieve some result similar to the one seen in this image, or at least similar to one seen in this image. But please put a chopper here as well, so it would look cool. Okay, and have fun.